All right, here is 1.2a number properties. You'll see that on this sheet we have two tables. This one on the top is called addition properties, and this one on the bottom is called multiplication properties. And here are some things that they have in common. So they both have four properties called commutative, associative, identity, and inverse. And these on top just give examples of those properties for addition situations. You'll notice everything has addition properties only. There's no multiplication, subtraction, division. And then down here, it has those same properties. I kind of want to ignore this one for a second. These are the similar properties to the ones on top, except these are examples of situations where those properties are being applied for multiplication only scenarios. And so we'll talk about the similarities and differences in the properties on top and bottom. And then this multiplication table also has an example of distributive property, which combines multiplication and addition. And we'll talk about that one as well. So starting with this top table, this first numerical example says that 2 plus 3 is equal to 3 plus 2. And we're not doing the math here. So what I mean is we're not simplifying the left side to 5 and the right side to 5. We're not performing any actual operations. It's just an illustration of a numerical property that's called commutative, and it says if you're adding numbers, it doesn't matter what order you add them in, you're going to get the same answer. So whether 2 is listed before 3 or 3 is listed before 2, because this is addition, we'll get the same answer. So basically, commutative property says that the order doesn't matter when you're adding. And then this column over here is just to write your own example. And I'll ask you to pause the video in a moment and take a minute and write your own. The associative property, you'll notice that in this case, the order is the same. On the left side, the numbers go 2, 3, 4. And on the right side, the numbers go 2, 3, 4. So in this property, the order hasn't changed. What's changed is where the parentheses are. They are grouping different numbers together. So on the left, the 3 and the 4 are grouped together. And on the right, the 2 and 3 are grouped together. And we know if we were simplifying this answer and we would use the order of operations, we would do parentheses first. So 3 plus 4 is 7. And then we would add this 2 and get 9. If the 2 and 3 were grouped together instead, we would start there. We would say 2 plus 3 is 5, and then add this 4 and get 9. So either way, we're getting the same answer. So associative property tells me that when I'm adding multiple things together, the grouping can change, but it won't change the final answer. So associative is telling us that here that grouping doesn't matter. So take a minute and pause your video and write your own example for commutative and associative. So here are mine. 5 plus 7 is equal to 7 plus 5. And then for associative property, my numbers are 8, 9, 3. 8, 9, 3, same order on both sides. But on the left side, I grouped the 8 and 9 together. And on the second side, I grouped the 9 and 3. And then here we have identity property, which says that any number, so in this specific example, it's 2. So any number plus 0 is going to equal itself, or its identical value. So another example would be 10 plus 0 equals 10. And then in this last property right here, the inverse property, this is inverse for addition, sometimes called additive inverse. And it's telling me that if I take a number and add it to its opposite, so negative 2 is the opposite of 2, or its inverse. So I take a number and add its inverse, that will equal 0. So they will cancel each other out. So another example might be 4 plus -4 will equal 0. We use these two properties when we're solving equations, and we talked about this in class. I don't want to take up time from the video, but let me know in class if you want me to talk about how we use these things when we're solving an equation like x plus 5 equals 9. And then some notes down here. I just want you to write two quick things that will help you remember which one is commutative and which is associative. So for commutative, think about your commute to school, right? That means the route that you take to school. Like when I'm leaving my house to get to the school, there's two different ways or two different commutes that I can take from my house. And it doesn't really matter which one I choose, I'm still going to get to the school. So it doesn't matter the order I drive to work, I get the same place. So your commute is like the order that you get somewhere doesn't matter. So commutative property order doesn't matter. And then my trick for associative is to think about this word associates. That kind of means friends, and you have a friend group. So associates, associative property, grouping doesn't matter. And then for this table down here, it's super similar, but this time with multiplication. So the commutative property for multiplication says that if you're multiplying numbers, and this doesn't work for division, similarly up here, these properties are not going to work for subtraction. 2 times 3 is going to give me the same thing as 3 times 2. With associative property, if you're multiplying multiple things, the grouping of them doesn't matter. Notice how the order stayed the same here, 2, 3, 4, 2, 3, 4. The grouping changed, but if you follow your order of operations, you'll still end up with the same answer, regardless of which two numbers are grouped together in the beginning. So pause your video and write your own example of these two properties. All right, so here are my examples. 6 times 5 equals 5 times 6. And for associative, my order of my numbers was 4, 3, 7, 4, 3, 7. But on the left side, I grouped the first two together, and on the right side, I grouped the second two together. We're going to skip distributive property for just a second, and I'm going to go to identity. So the identity for addition said 2 plus 0 equals itself. Well, for multiplication, it's not plus 0, it's times 1. 2 times 1 equals itself 2. So similarly, 9 times 1 would be identical to 9 for the identity property. And then for additive inverse up here, it was 2 plus -2 would be 0. So those are opposites of each other when you're adding. When you're multiplying, the opposite of a number means it's inverse. It's multiplicative inverse. So if I'm starting with 2, its inverse is 1 over 2. If I have 5, its inverse is 1 over 5. The inverse of 7 is 1 over 7. And when you multiply inverses together, they cancel each other out and leave you with 1. So an example would be 12 times its inverse 1 over 12 is equal to 1. And again, in class, we talked about how we use these properties without realizing it when we're solving equations. Again, I'm not going to take up video time for it, but let me know if you want to talk about it. And then for distributive property here, this is telling me that if I am adding two numbers inside of a grouping, and in front of that group, I'm multiplying it by a number, then I can rewrite this as that number times the first term plus that number times the second term. So whatever number's out front, I multiply it by the first number here. Then I take that number out front and multiply it by the second number, and I'm going to add those things. So we're distributing this 2 to the 3 using multiplication and 2 to the 4 using multiplication. So another example over here might be 5 times 2 plus 6. That means, what this means, I have 5 groups of 2 plus 6. So I have 2 plus 6, 2 plus 6, 2 plus 6, 2 plus 6, 2 plus 6. But I don't want to write out 5 groups of that. So instead I say, I'll do this mathematically. I have 5 groups of 2, and repeated addition or groups is multiplication. So I have 5 2s plus 5 6s. That's what the distributive property says. Now, if we're following order of operations, we would probably just do this math in here. 3 plus 4 is 7, and then times 2. This is just an illustration of the property. Usually we have a variable inside here, and then that's when we would distribute the number outside. So some notes I want you to write down here are this. Distributive property is the only one that combines adding and multiplication. Distributive property is the only one that combines add and multiply. The other properties have either add or multiply. On the other properties, it's either all addition or all multiplication. They're not being combined. And also remember that the other properties do not work for subtraction or division.